Yeah, now we are going to discuss superelevation. So, what do you mean by superelevation? Now, you can see here the road is slanted. Okay. Now, this is an actual picture that road being slanted. Okay. So here you can see now there comes the now you can see there comes centrifugal force, right? So centrifugal force usually it goes from here to here, the same thing, right? So check the direction, right? And now this is the weight is acting like this. So with this slanting, the weight supports component of the weight supports the centrifugal force. Okay, so these are some of the words that we use to describe superelevation, that is cant, camber, or superelevation. It's the difference in elevation of two road edges, now, if you consider this one from the center to the edge, there is a difference in elevation of two road edges. Okay, designers ensure that a curved road is sloped so it is higher on the outside of the curve. Outside of the curve, what do you mean by outside of the curve? So when it comes to a curve, okay, shall I draw? Now if I draw a curve, my drawings are not very proper, right? So this is the inner side of the curve, because if this is the center, this is the inner side of the curve, this is the outer side of the curve, right? So designers ensure that a curved road is sloped so it is higher on the outside of the curve. So this is the outside of the curve. Super elevation allows part of a vehicle's weight to assist in maintaining a circular path. Understood, right? It reduces the required amount of side friction between the tires and road surface when driving in a circular path. Otherwise, what happens? Otherwise, what happens? Side friction has to balance the centrifugal force alone. Side friction alone has to balance the centrifugal force. So that is not going to work. So why? So there may be some tire wear and very much very much uncomfortable for the people who are traveling by the vehicle. These things could happen. If or the worst is that the vehicle can be dragged away. Okay, the vehicle can be dragged away outside of the curve, right? So this is important for the safety and comfort of all road users. Okay, the amount of super elevation depends mainly on the operating speed of the curve and the curve radius, with more super elevation applied on tighter curves. What do you mean by tighter curves? Narrow curves. Okay, the radius is narrow, right? So this is a kind of an actual phenomenon. Okay, so if you just think on this, now maybe you might have felt when you travel in a car, even though either you drive it or not. So when you are taking a curve in a very high speed, you might have felt that you are being, yeah, right, you might have felt that you have been dragged away. Okay, you have been dragged away to one side. That is always outward of the curve, right? The amount of super elevation depends mainly on the operating speed of the curve and the curve radius, with more super elevation applied on tighter curves, right? However, with the need to drain water off the road surface, there is a minimum amount of super elevation applied to all curves. So that is not super elevation after all, that we call normal crosswalk. I'll draw it and show. Now this is called normal crossflow. Why can't we why can't we build a road like this? Huh? Flat curve? No. Flat surface? Then what about drainage? So this is called a normal crossflow. Please note down, right? So this is called a super elevated road. Okay. So we are going to discuss the factors. We are going to discuss the factors that are contributing to this phenomena of super elevation. There are many factors limiting how much super elevation to use. So what are these? Stability of high laden commercial vehicles. What is it? High laden commercial vehicles? Their height is, you know, they are having some kind of some big height. Okay. Then stability of loads on trucks. If you are going to provide lot of super elevation, very high super elevation, these vehicles can topple. Okay. Then tendency of the rear wheels of slow moving vehicles to track towards the center of the turn. Okay. So if the vehicle is traveling in a very slow motion, so if your super elevation is very high, so it can track towards the center of the turn. Then the sorry, appearance, particularly in flat terrain and in urban areas. Now in urban areas, if you are going to provide very high super elevation, that is very ugly. Then effect on out of control vehicles leaving the inside of the curve. If you are going to provide very high super elevation, if an errand driver, who is an errand driver? Who is an errand driver? Errand driver is who is being dragged away from the centrifugal force. Okay, so there will be, even with a very high super elevation, if he is going to be dragged away from the centrifugal force, that means he has traveled in a very high design speed. So it will be, kind of uh, accident prone scenario. Okay, then tendency of vehicles to slide on road surface in frost and icy conditions. So that is not relevant to us. So we are going to discuss about standards. So this may be a little bit boring for you because that is theory stuff. Anyway, we'll have to study these things if you are going to follow highway engineering. So the super elevation adapter is selected for safety, comfort and appearance. That is what we have discussed so far. Use of maximum super elevation should be restricted to mountainous terrain or places where there are physical obstructions which limit the radius of the particular curve with respect to the adjacent curve. The super elevation development should be done gradually over a distance without appreciable reduction in speed of safety and with comfort. Now, do you remember that in the morning session I drew the super elevation development? So that should be done gradually over a distance without appreciable reduction in speed or safety and with comfort. The maximum super elevation varies from 10% in mountainous terrain and 8% in rolling terrain to 6% in flat terrain. So now last week I discussed what is this mountainous terrain and rolling terrain and flat terrain. If you have, if you don't have any idea what is this, now those who have joined today, so you can refer my lecture notes of the previous week. And now as a rule of thumb, I can tell you like this. I think everybody has been to Candy at least one time in your life. Okay, so just think, starting from Colombo, say up to where? Varakapala. Just think that is flat terrain. Okay, and then say from Varakapallu to Kegol, just think that is the rolling terrain. And this Kadugannav area. Okay, Kadugannav area, that is mountainous terrain. And from Kadugannav to Kandy, that is again rolling terrain. Okay, just have some basic idea like this. But that is not the definition, right? If I ask you to write the definition, don't write like that. There are some definitions. What should be the corridor? What is a road corridor? Road corridor is everything inside the road. Okay, everything inside the road and how it runs in the, in the terrain. Okay, so now even though they say maximum super elevation varies from 10% to 6%, now in practice, of course, we don't go for such high values like 10% or 6%. Now it is a flat terrain, usually we don't go beyond 4% because the one problem is that is very ugly. Other problem is if you are going to have very high super elevation, it's difficult to give access to the adjacent houses. Okay, then we have to discuss a very important theory called axis of rotation. Okay, now please listen carefully. The cross fall is rotated about a line in order to adapt super elevation development at the curves. Okay, now there is a cross fall and it is rotated about a line. So what is this line? That line is defined as the axis of rotation. Okay, I'll draw and show you. Now just think, this is your road, right? Road cross section. Now this is my road center line. Okay, now can you see that rod is rotated around this line, center line. So this is called the axis of rotation. So in the normal cross fall it can be like this, and when it anyway, if it is super elevated it can be like this, right? So this is the line around which that cross fall is being rotated. So it is called the axis of rotation. So what happens if it is a you know uh, a road with a center median? So it will be like this, right? It will be like this. Now your axis, sorry, right? Now your axis of rotation will be like this. This is your axis of rotation. Okay, and same way, this is your axis of rotation. Why? Because this is being rotated along these two lines. Okay, if you consider the LHS, this is your axis of rotation. If you consider RHS, this is your axis of rotation. Now, for an undivided road, axis of rotation is, of course, the center line. Now, again, there is something called wider median and narrow median. Now, in our road, Sri Lanka, we have minor, so narrow medians, right? If it is narrow median, we don't have axis of rotation like this. Instead, we take center line as the axis of rotation. Now even though there is center median, what we do is we rotate along this center line. So that means just as same as it is being rotated around, it is just as same as it is like this. Understood? But if it is wider median, say now in our roads we have the center median as 1.5 meters. Okay, so that is a narrow median. If we are going to have say 3 meter median, then of course your axis of rotation is like this. If it is lesser, a narrow median, your axis of rotation is the center line itself. Okay. For two-lane undivided road means without center median. Usually the center line of the road is taken as the axis of rotation. In the case of wide medians, it is general practice to assume the median edge or pavement or shoulder as the axis of rotation. Now remember here the shoulder is not the edge shoulder, right? Now maybe you have seen in expressways we have a inner shoulder also. Okay, inner shoulder is the within now near the center median there is another shoulder. That is called the inner shoulder. Okay, and outside of the road there is another shoulder. Now even in the national roads also we are having, we call it an outer shoulder, right? So this is the theory that we are going to discuss. Super elevation development length. Okay, super elevation development length. Now, do you know what is super elevation development length? In the morning session I described. Now usually our normal crossfall is minus 2.5, right? So from minus 2.5, if your super elevation is say 3%, you have to come from minus 2.5 to 3%, right? That cannot be developed instantaneously. It has to come gradually. So that is what you call the super elevation development length. That I told you last time in the last session. So I think you understand. A change from normal crossfall to super elevation occurs as the road changes from straight to curved alignment. That is understood, right? In the straight section, it is minus 2.5 both way. And when it comes to the curved alignment, it becomes super elevated. The length required to develop superelevation should be adequate to ensure a good appearance and give satisfactory riding quality. So it should not be abrupt. There should not be an abrupt change. So the superelevation development should be gradual. There are a number of methods to calculate superelevation development length, among which following hold the dominance in Sri Lankan practice. So there are two methods. One is relative gradient method. The other one is rate of pavement rotation method. So we are going to discuss these two methods. Right? Now can you see these things? So how the superelevation development is happening? So maybe yeah, so I have forwarded these lecture notes to Mr. Vasant. Okay, so you can get the soft copy also. Please get the soft copies as well, because then of course you can enlarge these things and check, right? Because otherwise if it is a printout, sometimes these are not very clear, right? So here you can see from minus 2.5 it reaches the level point and then it goes to the super elevated area. So here what happens is the so one side, the other side is it is coming up to minus 2.5. Here if you check, this is plus 2.5, here minus 2.5 up to minus 2.5, it is coming like this. Then there comes so it goes to minus a, if it is 5% super elevation, it is minus 5% super elevation. Okay, so this is how the super elevation is happening, right? So now you know this whole length, from this point to this point is called the super elevation development length, from this point to this point, right? So then uh, to calculate the super elevation development length, there is an equation. The minimum length of super elevation development from this method can be calculated from the following equation, right? LE equals W into E plus N divided by GR. Now please note down what are these things, right? Please note down what are these things. They are not in the lecture note. LE is super elevation development length. Please note down now, because there can be an exam question on this. LE is super elevation development length. W is half carriageway width. W is half carriageway width. Half carriageway width means lane width plus the shoulder widths. Please write shoulder widths plural, not shoulder width, because there can be two shoulders. Okay, and lane widths also, because maybe there may be more than one lane. One side I am talking. Okay, and E is super elevation as a percentage, and N is normal crossfall, that is minus 2.5, not minus, plus, plus 2.5. It should be minus, but you are applying here plus. And GR is relative gradient. GR is relative gradient, that is given in a table. Here, maximum relative gradient. So if you are going to design for 50 kmph, one lane, that is one side, right? So your maximum relative gradient is 0.71. If it is two lane, relative gradient is 1.07, and it is more than two lane, it is 1.42. And if your design speed is 70, for one lane one side, it is 0.56, two lane one side, 0.84, right? Then the other one is rate of pavement rotation method. Rate of pavement rotation method. The rate of rotation is defined as a change in the crossfall from normal crossfall to full super elevation over the time required by a vehicle traveling as the design speed along the length where the change occurs. The length of super elevation development is given by the following expression. LE equals E plus N into V divided by 3.6 into beta. Now here also please note down what are these stand for. E is super elevation in percentage. N is normal crossfall in percentage. V is design speed in kmph. And beta is the rate of pavement rotation, and that is capitalized. The rate of pavement rotation is recommended to be 0.035 radians per second for design speeds less than 80 kmph, and to be 0.025 radians per second for design speed greater than or equal to 80 kmph. So I'll give you a little hint. Now rate of pavement rotation is going to be dominant if your design speed is greater than 80. For all the speeds lesser than 80 kmph, uh, the other one, relative gradient method, is going to be dominant. So you have to calculate the super elevation development based on relative gradient method as well as the rate of pavement rotation method, and then you have to take the maximum of it. Okay, understand? If in an examination question, if they ask you to calculate the super elevation development length, right? Now you know if it is lesser than 80, of course the relative gradient method is going to be dominant. But in an exam question, in the industry you can do that. But in the exam question, you have to calculate in both methods and give the dominant one. Okay, so if in an exam question, if they ask you to find the superelevation development length, find the superelevation development length according to the relative gradient method, and find the superelevation development length based on the rate of pavement rotation method, and then get the maximum of it, and you round off into the highest three. Okay, 3, THREE. Why I stress so much? Because you have to have super elevation development, uh, two-thirds of it outside the curve and one-third inside of the curve. Is it like Greek to you? No, it is not like Greek to you. Just think that if this is the, say this is the curve, right? So usually one third of the super elevation development is inside the curve, two-thirds of the super elevation development is outside the curve. Okay. Ah. Here, yeah, there is a method to calculate. Superelevation is now you know we'll go to superelevation calculation. Superelevation is tilting the roadway to help offset centripetal forces which are developing as the vehicle goes around a curve along with friction, right? They are the forces that keep a vehicle from going off the road. This note aims to elaborate some of the equations that are necessary to develop superelevation in different curves. So please understand what are these things. Begin full super, begin normal crown, curve tangent point, common tangent point. So the full text is given. Degree of superelevation of the first curve, degree of superelevation of the second curve, n full super, n normal crown. So you can just refer these things, right? LC is level crown, LE1 length of superelevation development of the first curve, LE2 length of superelevation development of the second curve, and then LHS left hand side of roadway, N is normal crown, RC is reverse crown, right hand side of roadway, RHS TC is tangent to curve point. Here, this is how you are going to calculate the super elevation for a simple curve. Now, can you see here? This is anti-clockwise direction. If it is just think that you are walking or you are driving along this curve, now do you know which side should be elevated? RHS side. So this is the RHS super elevation. Okay. And now here these are the now what is n normal crown? This one. So then the equation is there. Tangent to curve point minus 3.2 over 3 LE. Then reverse crown is this point. Here can you see that the super elevation starts reversing here. That is why it is called reverse. And here begin full super elevation. Begin full super elevation. That is why it is called begin full super. Here here it should be EFS, right? N full super. N full super elevation. Here again reverse crown. And then here begin normal crown. So all the equations are there. And this is for a reverse curve. You know in the reverse curve what happens? This is clockwise direction curve, anti-clockwise direction curve. So the super elevation reverses at what? At which point? At the you know the common tangent point, right? And then these are the equations. But we will not ask you question that much deep, right? And then closely spaced reverse curves, right? Here also the equations are different. Okay. And then compound curves and closely spaced compound curves. I am just telling you because you cannot find these things from any textbook. Okay, that is only with the practice in the industry that I am giving you. So take the benefit of it, right? And these are the equations, right? So I don't think you can get this from any textbook in highway engineering. But anyway, I give you to you. So if you are interested, you can calculate these super elevation values yourself. Okay.